Next, we'll load the data into Power BI by going to Get Data. And we already know it's a text CSV file. Click on text CSV and load the data, purchase card transactions data. Once it's loaded, you can do all the transformations. It will take a little bit time for the Power Query window to open up. Once it opens up, you can do those changes. What we thought, the step one is we want to clean up the data. And prior to that, you can see the Navigator window shows you what type of file you're bringing in. And it also identified the columns and the headers. And if you want, you can refresh the data by clicking on this button. And you can also extract table using examples. And we have three options: load, transform data, cancel data. And in case if you want to transform, you can click on the transform data. In our case, we want to make some changes. So let us go ahead and click on the transform data. Once you click on the transform data, then the Power Query window will open up. And in this window, we can, in this Power Query Editor window, we can make all the changes. Let us wait for the data to appear. Now you can see on the left, that's the query name. And on the right, you can see the properties and also the applied steps. Power Query has identified and promoted headers and changed some data types of the columns. And once you have this information, we can go ahead and make any kind of changes, right? As you can see on the top ribbon, you have those options. And if people are coming from any kind of GUI-driven applications like Microsoft Office or something, they are aware of the menu items. And you can click on all those tabs. You can click on transform if you want to change the data. And you want to add a column or view the column distribution or profile. It will appear about the column, validity, error, and empty. It will show up. And you have additional tools as such. So now that we have understood the basic components of the ribbon, let us go ahead. We have already identified the transaction amount as the target column. Let us try to filter out zeros and negatives. As we can see, there are negative values too. By using number filter, greater than or equal to 1, we can filter those values out. That way, because Benford needs a non-zero digit as a leftmost digit. So once we do this, we are kind of filtering out those values. Now that we have all those values filtered out, next step is to kind of move this column to the end so that when we create a leading digit in the Power BI desktop, it will be easy for us to compare transaction amount values and also the leading digit. And you can make changes to the name of the steps by right-clicking on the step and naming it appropriately. Now that we are done, we are ready to click on close and apply so that these changes will take place. They're processed. Once you click on close and apply, it will take a little bit while because it's a large data set, 84 MB data set. Probably after filtering, we have maybe 82 MB or something. And in case if you want to make further changes, you can discard the changes and go back to the previous window. And it is very intuitive. It will tell you, this window will tell you what is happening. It will give you the progress. It is saying that it is creating connection in the model. And if you want to cancel, you can cancel by clicking this button too. And it is telling you all those things. The progress is being shown on the highlighted part. It will tell you how many kilobytes have been loaded. Once it loads, it will go into the data section. And as you can see, it's showing up how many MB of your data is being processed and loaded. And you can also see the table from the table view option on the left panel too. So it is everywhere on this window. It is telling you that these are the changes. And the bottom right, there is an icon gear. You can change your personal settings, and you can also change the canvas values by using the toggle button on the bottom. So and also I wanted to highlight another point is you can after you create visuals, you can also click on this mobile thing and you can see those visuals. Every time you add pages, you can click on the plus button. Those pages are being added. Now we see that the progress has been made, 82.1 MB from the data is being loaded into the data model. And once it is done, you have a number of rows that have been loaded that is also being displayed. Once we have that, we have the table in our Power BI desktop. And if you remember, we have to make certain changes. We have to create a new column, which is we are going to extract the leftmost digit from the transaction column. And we can see all those columns appearing here. So it's time for us to go to table view and try to make the changes. We'll create a new column. As you can see on the panel left, you have different views. We'll click on the table view, and the data is appearing up here, obviously. And you have certain tools on the top. If you see new measure, you can create a quick measure, you can create a new column or a new table. Our idea is that we have to create a column next to the transaction column. So we'll go ahead and click on new column button so that the new column options are available for us. Then we can add our DAX expression in that value area and create a new column. So once we click on that, we have that column. We will name the column appropriately. We will name it as probably, I think, leading digit should be the appropriate column name. So we'll name it as leading digit. And here we can use a function called as left. It expects two arguments. So the first one would be the transaction amount, and we want to retrieve the leftmost one digit. So we can do that. And once we commit to it, you have your column appearing on the right. And in case if you want, you can change the type of this column too. From this is a text column, obviously, right? If you can see, if you want to verify the values randomly, go to those rows and look at the data, transaction amount value, and also the extracted value. So I think we are good to go. Our column is ready. And in case, like I said, in case if you want to change this into a number or something, you can wrap this in an integer function. So that it will be a number column. I mean, you don't have to do this step, but just in case, if you want to, you have this option available to commit to it. And the leading digit column is ready for us, and we can go back to the report view. Once we are in report view, we can start creating all the measures. So we can go to the purchase card transaction table and try to drag leading digits onto the canvas. Create a table so that the leading digits appear. Initially it is aggregated, so we'll try to make sure that it is not summarized. So click on don't summarize, and once you do that, you have your leading digits in the table 1 through 9. Perfect. And the next logical step for us is to create a frequency. So we will create a new measure, and once we create a new measure, we can count the frequencies. So obviously in this measure, we'll be using the count function, and we will name the measure as count digit. That would be the appropriate name. Once we type that and try to enter our formula, DAX formula, we can say count. What do we want to count? We want to count the leading digits. Commit to it. Once we commit, and in case if you want, you can format to. You can click on the comma option there, so that you have your 1,000 separators too. Once we have that, we can drag that particular measure onto the table. Once we drag that onto our table visual, and you can see the various frequencies appearing. One is appearing 168, 74, and so on. So I think we are good here. The next step for us is to create a percentage. In Excel, we could easily do it by changing the cell value. But here we have to create another measure. And we already know that we have to divide say for example 168.74 over the total 548.957. So what we could do is we can go to the table, right click on new measure. Once we do that, we have an option. We can create the measure up here in the area, and we will name the measure appropriately. We can say that it's observed percentage. so that we have that percentage values. We'll go ahead and use the divide function. It expects numerator and denominator. We already know that numerator could be count digits. We have already created a measure. And for the denominator, we can count rows and add the table. It will count all the rows of the particular table we are working on, which is purchase card transactions. Once we do that, we can commit to it. Once we commit, that percentage values are calculated. And in case if you want, you can change that into percentage too. Once we do that, we can drag this observed percentage into our table visual and see how it looks. Drag it onto the table visual. And we see that there is, this is not correct, right? So for every row, it is showing 100%. So we know that that's not the correct value. So we can go back and fix that by using all. We'll wrap, after count rows, we'll add all so that it will ignore all the filters. So we'll use all function up there. So once we wrap this around all, I think the problem will be fixed. We will commit to it after modifying the measure. And once we modify and commit to it, we can see that those values are changing here, and those values look correct here. So if you see again, all the values have changed. Now, there are a couple of other steps too here, right? Next, we have to create a Benford percentage. We can create another measure, and we'll name that measure as Benford percentage appropriately. And we will use SumX function in this measure. And first option will be the argument which is expected is the table, and second argument is the expression. So we will use values function so that we can get distinct values from our leading digit, so that we get only 1 through 9 as the distinct values from that column. And this is the table, and the second argument expected is expression. We already know the formula how to create Benford distribution. It's a common logarithm 1 plus 1 by leading digit. So we enter those that code up there, and we'll close the parenthesis, and we will commit to it. So now that we have Benford's percentage, in case if you want, you can format it to percentage, and then drag that over onto our table visual. So that way we can see the comparison between Benford and the observed values. So once we resize the table up here, and we see that the comparison is there. And in case if you want, you can add another column, another measure up here. Sorry, we can say that it's a deviation. It could be from Benford to observed or observed to Benford. It is up to you. So in our case, I just wanted to use deviation percentage. I want to deduct Benford from, I want to deduct observed from Benford percentage. So I will enter that code up there. I'll commit to it. Once I do that, in case if I want, I can change it to format, to percentage format. And once I do that, I can drag that deviation onto the table visual. So once I select the deviation and drag it onto my table visual, I can see the deviations. Now that I have that, I can visualize it in a line and clustered columns. So I will copy the visual, I'll paste it in a different area, and go to my visual options, and I can select my line and clustered column chart up there and click on it, and the visual automatically changes from table to line and clustered. We don't need count digits, so we'll just try to clean it up. We'll remove that, and we can kind of move a deviation into tooltips so that the visual looks cleaner. And whenever you hover over our visual, you can see the deviations too. And also, in case if you want, you can remove the title and legend. In our case, I want to remove the title and legend, and I want to add data labels. Once I add data labels, I can see the percentages. So I will remove the legend again. This is the line and clustered chart, and I can make a little bit changes. I want those columns to pop out, and I can change the color of observed, and also I will change the color of Benford. So that way I can visually notice the differences. The column colors are changed, and I can resize the line and clustered column chart, and I can see already I can see the comparisons. But I want to make sure that the x-axis is changed from continuous to categorical, so that my values appear, and I'll make the changes sorting the axis, x-axis, by ascending values of leading digit, so that I get 1 through 9 in ascending manner. So I think the visual looks good now. And in case if you want to add a curve there for the line y-axis, you can add, and we will add probably Benford percentage up there, so that it appears as a curve. Visually also it is appealing. So I'll go drag my Benford percentage or observed. It is up to you whether you want to add observed or your Benford. It doesn't matter. It is your call. Initially, we'll try to add observed and try to go to the data labels. Probably turn off the unwanted ones. In this case, initially we'll turn off the data labels for observed, so that the visual looks a bit cleaner for Benford. Sorry. And we will turn off the values for Benford. Once we do that, we can see it a little bit cleaner. And I think I will try to change it from observed to Benford, so that that way it will be much cleaner. I don't want to have my observed on my line y-axis. I'll go ahead and make that change. I will remove my observed from my line y-axis, and I'll bring my Benford percentage onto my line y-axis. I will select that from the table, and the measure which we have created, I'll drag onto the table, the visual, and the visual looks cleaner now. We can see those deviations too. So that that looks good. I think we have achieved the things which we wanted to do. In case if you want to have those dimensions as filters, for example, if you have agency, you have your vendor state and assets, right? There are some dimensions also. So you want to use them as slicers. So like, for example, agency, vendor name, and vendor state, you want to still look at the values, the Benford visual and also the table by applying those slicers. So let us see if it is working out. Let us create the slicer for agency. Let us change it into a drop down, so that it is visually appealing too. So let us go ahead and change that into a drop down by clicking more options. And if you pan to the right, you can go ahead and from the drop down, you can change it into from vertical list to drop down. Once we do that, we have the slicer up ready, and we'll also create another slicer. Maybe we will create a slicer for vendor, state, or province, so that that way we have two slicers on the top. We will initially use say vendor state, so that particular column as a slicer, and we'll repeat the same thing for this particular slicer. We will probably rather use vendor name and change that into a drop down. So we are ready with our slicers. So let us try to select one value from the slicer agency. If you click on advisory neighborhood commission, and the values in the table and visual look different. I don't think so they are showing the correct values. I think there is a way for us to fix it. So let us go back to our observed measure which we have created, and we can make minor modifications here. We can modify the code instead of all, which removes all filters. We'll use all selected, and that way whenever the slices are coming from outside the visual, those slices are honored. So we can click on all selected, then commit to it. Once we do that, once we go back to the slicer, select advisory neighborhood commission, it is working. And we'll also try to select some other vendor name randomly. So you can see that those values are changed. I think those look good. Of course, most of the vendors or most of the agencies might not have used all the purchases or when they paid to vendors. 1 through 9. So some of them don't show up all the digits. For some they show 1 through 9. So now that we have the visual working for all the 2 slicers, so I think we have achieved a new way of looking at Benford when we have multiple slicers working on the visual. Still we can see the Benford values. So that should be, I think, a good achievement for us now that we have those things up here. So let us go ahead and make changes to the data category of vendor state, because in case if we want to visualize that in a map option, so we'll go ahead and click another page, and select the map, whatever map you are comfortable with. Click on that map. Even though this is we are using the vendor state as a state or province, it might not be correct. In case if you have longitude and latitude, it is accurate. But I think I just wanted to make sure that we will be able to use one of the columns in our data set to at least see the map, so that we have that option being used. So let us try to add bubble size transaction amount. This is counting. So let us, let us create a new measure. Let us quickly create it. We will call it as total transaction amount. We will try to use that as a new measure name. Maybe we'll use as total amount. Then we will try to sum the values in the transaction amount column. So by using, by wrapping that in a sum function, we'll be able to get that value, total value for all the transactions. So once we close the parenthesis and commit to it, and we can change the formatting to probably currency. So that way, at least we have, I hope that these are US currencies. Obviously, they have paid those vendors by using US currency. So now we'll go ahead and drag that onto the bubble size, and you see those changes are appearing. So I think we are good now. Now that we have done this, we will probably in the next example, we'll see in case if there are multiple numeric columns in a data set. So we have done only for one column. Now let us try to, in the next video, we'll try to load a data set which has multiple numeric columns, and we'll try to repeat what we did for Benford. Thank you. See you in the next video.